So I'm Eric. I work at DGG. We do like optimization of 3D content, and I'm part of the 3D Commerce Working Group. I've been contributing to Khronos calls for about 7-8 years now, so quite a while. Before this, I was at Wayfair for 7 years, leading the 3D team there, and so we're heavy contributors to all this. And one of the things the 3D Commerce Group has been working on lately is videos that kind of explain what 3D commerce is, but also why 3D is important to companies and how you can actually get a return on your investment with 3D. And so we targeted actual use cases with real companies that are really getting customers to buy things more often and get more satisfaction about their products. So one big thing that we have to deal with in 3D commerce is, like at Wayfair, it's when you sell stuff to people and they're looking at images online of the product, it may not match exactly what they get when they open the box at home. And so returns are a big problem. And so we're trying to work on ways to, as a group, figure out how we can improve that whole process so that we get less returns and customers are happier. And we find that 3D really helps that whole process because you can turn the thing around. You can look at it from multiple angles. You can use augmented reality to see it in your space. See if it fits in your space is like a big use case, right? It's awesome to be able to use AR and actually see, oh, this couch is way too big for my space, right? Or that the rug doesn't fit, that kind of thing. So we talk about that in a lot of these videos, and we're going to be making more videos to talk about with decision makers about why they chose to integrate 3D into their pipeline and how it worked out for them. So then we're going to talk about visual consistency. And I changed these slides around, so I'll handle the first few, and then Emmett will come up and grab some detail. So I wanted to show, this is an asset that we have in the 3D commerce, or in the 3D asset sample asset repo for Khronos. So we have a whole bunch of assets, and some of them are e-commerce assets that are real-world products that we sell. And the challenge is real between what we show in a web viewer versus what we show in an AR device. And we have to deal with that as e-commerce companies. We want to make sure that the content looks the same regardless, and the customer doesn't lose confidence in what they're seeing as being an accurate representation of the product. So I love QR codes because you can grab stuff. So that's a QR code right to a live viewer where you can look at stuff in AR in this actual asset. And so towards that end, in 3D commerce and 3D formats, we came up with asset creation guidelines, which is for actual 3D artists and 3D creatives to create stuff. And we canvassed all the companies that are working together in Khronos to figure out what are the best standards to actually make content. And we came to an agreement about, yeah, these are the great things that we should do. And that we should promote to the community to help people make stuff that works in multiple renderers and works across the whole ecosystem. So say if I make a model for the Amazon marketplace and for a particular merchant that actually makes a product, now that merchant owns that asset and they can use it on Wayfair, they can use it in IKEA, they could use it anywhere across the web and it'll work. And that's been a major problem in the past in terms of interoperability. So we wanted to come up with standards and ways to make it kind of easier for content creators to make best class assets. And also the sample assets repo. So I've contributed a bunch of models to that, and so have other companies, as a way both to provide real-world samples of real products that actually exist that you can buy, and we want to have virtual representations of those that kind of stress test GLTF. So we're testing, iridescence and transmission and glass and anisotropy, all those things that real-world items have, and we have to have those to represent them. But also we make a lot of test case assets that are great for unit tests and smoke testing and figuring out what does work and what doesn't work. So those are all freely downloadable, and they're made with really open source licenses so that it's really easy for you to reuse those in your own content. All right. And Emmett.
Thank you, Eric. Yeah, so going hand in hand with the sample assets is the render fidelity suite. And this is actually something that I helped develop and maintain over at the open source model viewer site. And it was something that we just thought was valuable in general. But now, wonderfully, Khronos has actually offered to take over ownership of this, and that I think is going to improve it and keep it much more up to date than I was able to on my own. But the purpose of this render fidelity suite is to show what is the state of render convergence, right? Because the real innovation of GLTF as a format was that it didn't actually specify a shader. It didn't say precisely how you were supposed to color the pixels on the screen. It showed physics, right? It's encoding physical parameters, which means it's future-proof. Physics isn't changing. What does change is our abilities to approximate it faster, more accurately. These things are improving all the time. And we want to give the community as much opportunity to improve as is possible. And so we showcase both rasterizers and path tracers, right? Path tracers have much more flexibility to be much more physically accurate, but those are both perfectly reasonable uses of GLTF. And that's great because the path tracers give the rasterizers something to aim at. We can now say, oh, this is what we should be trying to do. It might be impossible now, but it won't be impossible forever. The GPUs keep getting better, the research keeps improving, and we make use of that to move towards that. And so the render fidelity is not really there to cast judgment or to say like who's better than who. It's to allow everybody to look at all these different situations. It's a great place to find bugs. It's a great place to figure out even just how to set up renderers to be consistent. That's a big part of what we did with that, is just to make it so that you can actually know that, oh, by setting these particular options in these renderers, you can get them to look like another. Because that was a big confusion. Most of the time when I heard people saying like, oh, my GLTF doesn't really look the same in two different renderers, it wasn't actually because the renderers shaded things really wildly differently. It's just that they're different to set up. They have different APIs, and that takes some know-how. But you can look forward to this web page improving a lot. We're working right now to clean this up, make it better HTML, make it faster, make it easier to navigate, and more up to date. So I think that's going to be a huge improvement. Now I'm going to move into another thing I've been working on with Khronos. I've actually got a SIGGRAPH talk on this tomorrow, a little bit before noon, in a session called Love Me Some Color. So I'm going to go over the very basics of it here, but if you're interested, please come to my session, and I'll go into it in a bit more depth. But basically, one of the problems we identified with 3D commerce is that it's rather difficult for an artist to get products to show up the color that they expect on the screen. And this is a big issue because, right, like we have brand colors. Those things have to be precisely accurate. You're going to show these things right next to a photograph that's been photoshopped and color graded to get just the right product color that's been approved by the marketing team. If the 3D model doesn't match that, it's immediately obvious, right? These things are next to each other on a website. And this has been a huge thorn in the side of a lot of artists and QA folks in this domain. And what I finally realized was that actually the core of the problem was the tone mapping that we're applying. And this is the final stage. After all the physical part of rendering, you get your light back in floating point, incredibly bright, and you have to drag that down into the range that your monitor can show. But you have to do it in such a way that perceptually it looks right. And that's not a physical process, that's a perceptual process. And it's very difficult because it's not well defined. We were mostly using ACES tone mapping because it's a standard from the film industry, and I don't think anybody gave it too much of a thought. But upon doing a bit of data analysis, I realized that the reachable set of ACES is not very large. That's what you're looking at. Here on this corner of the screen, if you want canary yellow, you can't get it. There is no sRGB value, there is no lighting color that you can apply in your renderer to ever get canary yellow if you're going through ACES tone mapping. Why? Well, it wasn't really designed for this. It wasn't made for sRGB inputs. It wasn't made for e-commerce. It was made for the film industry, and they have a completely different set of requirements. So I have developed a new tone mapper that is quite simple, actually, and very fast, and designed specifically for the needs of e-commerce. And it's designed specifically so that you can say, I need this color to be output. I'm going to put that same sRGB value into my texture, and if I use grayscale studio lighting, I know that color is going to come out. It's going to get shaded, obviously, it's the point of PBR, but it's not going to get a hue skew, it's not going to get a saturation loss, it's going to actually be the color you expect. And so, you can see the example here, and if this is the real color of your car on the bottom here, you don't want it to show up under ACES tone mapping. That's not the same color of car. It might look good on its own, it might look fine in a movie, but if it doesn't match the actual product, that's a problem for selling it. So that's what we're working on here. And so this kind of moves us to more of a verifiable color workflow. And the real key here, right, is that what we've been dealing with in the e-commerce space, and I've dealt with this personally, helping the G Store at Google deal with selling our own products, is this loop is really expensive, right? You give your artists the product that they're supposed to make. They pick out their model colors in their textures. It goes over to the lighting group. They make some lighting to make it look good. It goes through the tone mapping that nobody's thought about. And then it comes back to quality assurance, and they say, the color's wrong, go fix it. And then it goes back. They say, I wonder what's wrong with the color. I thought I did a good job. And around and around. This is the bane of my existence. And the idea here is to break this loop. To say, now you can start out with what is the reference color swatch? How does marketing expect this to appear on the website? Start there. Now the artists can put that into their textures with confidence. The lighting. Yes, change the lighting to make the highlights look good and everything else, but keep it simple, grayscale, no color applied. You know you're not going to tweak your colors. Obviously, if you're going to go into AR, it's going to come under colored lighting, and that will make it look more realistic. It's going to be a different color, but that was intentional. But in these situations where it's on your website, you can say, oh, but under grayscale lighting, I know exactly how this is going to look. You go through the PBR neutral tone mapper, and now you know that when it comes down to quality assurance, if they want something changed, you don't have to go back to the model. Maybe you go and tweak the lighting or something like that. Maybe you go and tweak how it looks how it's displayed on the website, but the color is no longer this thing that you have to constantly bicker about whether it's right or wrong. So, again, the key here is if you already made your models, if you already went through this loop with ACES tone mapping, you've done as well as you can. Changing the tone mapping at the 11th hour is the last thing you want to do, right? Changing a tone mapper, if you've already gotten the colors that are perfect, is only going to make it worse. What this is useful for is if you're starting. If you're building a pipeline, if you're saying, oh, now we're going to make a bunch more models, that's the time to start looking at PBR neutral and to say everybody in the pipeline, from the artist to the QA engineer to the lighting engineer, all the way through to the website, uses the same PBR neutral, then you know you're all looking at it under the same situation, and you know you're not going to keep going through this loop. So, we talk now about like what's next. We talk about this stuff in the 3D Commerce group. So if anyone's interested in joining us, there's a lot of work to do here. This is the very first step, right? This tone mapper is not the end-all be-all. It is absolutely not for the things that filmic tone mappers are for. And if you apply it to like beautiful HDR images, it's going to look ugly because that's not what it's for. That's what filmic tone mappers are for. They've made different trade-offs. But nonetheless, we are going to have to look at further use cases, right? At some point, we're not going to be just locked in the sRGB world, right? There's more and more displays that are using P3, wide gamuts, HDR. Eventually, we're going to need those kinds of image formats in GLTF, in our models, right? And we're going to then need to map those gamuts from the model to the display. That is an even harder problem, but it's the job of tone mapping as well. We're going to have to do a bunch more development to hit all of those use cases. And there's other interesting use cases too, right? Like this is specifically called the PBR neutral tone mapper because it actually includes a correction for the Fresnel effect that we deal with in PBR. That's part of the reason that our colors end up desaturated all the time. But if you're not in a PBR workflow, you don't want to apply that correction. So there may be some parameters, there may be some other versions of this tone mapper for other use cases that could be valuable. But again, we're only going to know that if we get feedback from the community about what things are needed. But I think that what we really learned is that tone mapping had been the exclusive department of the film and game industry. And we've realized now that it's important for other rendering industries to think about what we need in these situations. There's a reason a lot of tone mappers exist. I'm sure this won't be the only one that we think about.
Nice. So you asked about apparel. Here it comes. We started in 3D Commerce. We started an apparel technical subgroup that specifically addresses issues that people have with apparel, special use cases, virtual try-ons, that kind of thing. We see that a lot of companies are dealing with how do I deal with these issues that they have with virtual try-on, where really you're trying to anchor a virtual asset to somebody's body and not have it clip through or not have it not fit. And there's a lot of companies that are actually using it right now today, even with the limitations. So you can do a virtual try-on with shoes, for example, and see Nike shoes on your feet or Adidas shoes. It's pretty cool. And we see that evolving a lot more. So special thanks to Patrick at Snapchat for really driving this effort. And he can't be here at SIGGRAPH, but that's him in the bottom corner there doing a virtual try-on. So one of the biggest challenges is just there's no standards for how to actually calibrate where on the face you're going to put things. So for example, the sunglasses that he's trying on are going a little bit low on his face, and the frames are actually interfering with his eyes, and they're not actually connecting with his ears. That's because we don't really have a standard for where those attachment points are and how to actually calculate those. And the woman on the right there, she's getting clipping where the actual glass is clipping with the Z buffer, and the depth buffer of the camera is clipping it through her cheeks. Or the try-on with the shoes are not, the heel of the shoe is clipping through the actual virtual occluder that's used to occlude the inside of the shoe, so you don't see the inside of the shoe on top of your real foot. So there are all kinds of challenges that we have to kind of deal with. And here, key findings that within the last year that this group has been meeting are that really the apparel industry has really different use cases and issues than a lot of other key e-commerce companies that we've been working with. They really focus on, product development and R&D into their specific use cases, as opposed to making interactive websites like a lot of other e-commerce giants are doing. And they're struggling to figure out, is this the return on investment that I want? Is this the right thing to be doing? And so they need guidance, right? And it's a different way of working, and we want more interaction with apparel makers in the 3D Commerce working group. So there's a real call to action for getting more involvement from other companies that actually have these problems and can come in and actually advise us, hey, these are the problems we're having. These are the solutions that we'd like to see. How can we work together to kind of develop these standards and come up with things that work across the whole industry? So standards kind of help push us that direction. So for example, they're working on like attachment points just for the ear. Like there are all these different kind of standard places to do ear piercings. And if we come up with specific locations, then we can actually detect those in a virtual try-on situation and say, oh, this one goes at the top of the ear or on the side of the ear. And it happens for the whole body. So, there's like top of the ear for where the glasses sit, or the top of the nose. And it goes out through the whole body. So they're looking at ISO standards for how attachment points are, and integrating with the FACS standard for how face phonemes are generated in the movie industry. And how can we integrate all those standards together to kind of come up with something that's usable and that lasts and that can become an ISO standard itself so that anybody can integrate it into their system. And that's pretty much it. So I think we're going to open it up for some more Q&A and a reminder about the free beer, which is awesome. But, again, like I said, this is a BOF, right? So it's birds of a feather. All of you are, I would assume, using GLTF and these standards. And if you're not, you're considering it, right? But what are the issues that you're facing or use cases that you want to get out of it? Because we really rely heavily on what does the industry want. And so we try to tailor our stuff to not only what we as member companies have to deal with, but what other people are finding.
Hi, thank you very much. I have a couple of questions about the e-commerce part. So one, just on the last point you made about placement on the body, the standard way for a long time has been use of landmarks. There are ISO standards, et cetera, for landmarks. Is there any plan to incorporate them in GLTF avatars? Is it like a standard way so you know, this ISO standard, this landmarks are present there, can be used for placement?
Yeah, I'm not specifically in that technical subgroup, but I know Patrick has been,
Okay.
they've been talking about 4 different extensions that they want to propose. And they're for joint placement. And I'm not sure what the other extensions are, but I bet that landmarks probably fit in with that. So that's something we can send back to the group and say, hey, this is something really interesting.
Yeah, that would be great. So just one more quick question. Also, a big bane of everyone's existence in the apparel, try-on, and related fields is the lack of an apparel standard to represent the garment asset itself as something other than just a 3D geometry shape. Is there, it's more of a question for everybody. Are people interested in discussing this more so that there can be an interchange between different 3D garment CAD software and being able to convert that to GLTF?
Yeah, I don't have the answer.
This is more of a.
Yeah, I
actually,
mean, that's an issue that we're seeing in our
all
clients that use either Browseware or Close 3D or
Exactly.
Marvelous or different tools, and they all have different ways of handling the physics of cloth, which is sometimes super
Exactly.
complex, right? You've got tensile strength and
Yeah, so the closest thing is really DXF ASTM, which is about 30 or 40 years old.
Yeah. I mean, I think the answer is yes. And I'd love to talk to you because we've seen the interest growing around apparel and try-on for like 4 years now. And and for try-ons, there are multiple standards out there, IEEE, ISO, X3D, they all, and we don't want to duplicate. We're trying to figure out how we can coordinate and produce something and then encapsulate whatever standards we want to use to let people use it through GLTF too without fighting. We want to find a way to collaborate. It's been a struggle to find the right forum and the right players and get everyone in the right place at the right time. But the interest continues to rise. So I think the time is approaching very soon now where there's going to be enough interest that we want to try and help gather all the right folks together. And on materials, it's exactly the same thing. And particularly for fur, and there are all kinds of challenges. And the GLTF community can help working with others in the industry. So I'd love your thoughts on how we can best collaborate. Yeah.
Thank you.
Just following up from that conversation, I would love to get my hands on how the technical side of that works. Currently, how the markers are supposed to connect up with the 3D assets now. I think it'd be interesting to see if that is something that could make sense to us and see if we can push that further and collaborate. Just a thought there, yeah.
Yeah, no, totally. I mean, as Eric's saying, Patrick has made an awesome start, and he's been reaching out to all of the humanoid and animation standards, and we've been learning from them, and they've been learning the 3D a little, but hopefully from us, and we are, I think, getting close. So again, I'll come over, we'll swap cards, and be delighted to involve you in that conversation as we figure it out. I'm hopeful that we can, by next SIGGRAPH, we can have some really tangible industry progress. We might not have like final specs, but we'll know where we're headed and we know who we're working with. I'm really hopeful the time is right to bring that group together. So.
For us, if we have 3D assets of all our products, so if we can anticipate what that's going to look like in the future, and we'll probably have to put markers on those products so it matches.
Yeah.
So the sooner we get that information, the better.
Yeah. Okay. Yep.
Actually, I believe we do have PR for these attachment points already on GitHub that we should point to, at least for the face markers and for the skeleton.
Yeah, I know Patrick did a presentation at PI recently. And so there's a whole deck with a whole bunch of information and tons of information that they've gathered. And so it's actively being worked on. But like involving yourself in that is super useful, even just as just a point of reference, right? To give ideas, or you could even come and present to the working group on, you know, what are the challenges you're facing and how are you actually integrating it now and what are the problems that you want to address. That's super useful to the working group because then we can see, oh yeah, these are actual use cases that we need to incorporate into the standards. Yeah.
Hey, yeah. So I guess my question kind of is based around the GLTFX and the AEC side of things, but for the lighting specifically, is there any conversation around implementing IES profiles?
IES has been brought to the working groups, and we did look at that. At the point that in time it was done, it was thought to be too specific to to the particular industry and not useful in a general sense. So I believe it was NVIDIA that brought those proposals. They developed their whole set of extensions on their own, and GLTF does have a mechanism to have non-Khronos, non-ratified extensions included into the ecosystem. Not sure exactly where in the web that you can find them, but I would look up GLTF IES.
Great, thank you.
Oh, actually, it's there. Yeah, we have this IAS extension on GitHub. Yeah, you can use it right now.
Yeah, kind of towards that end too, we've talked about, with external referencing, when a GLTF has lighting inside of it, and you put it next to another GLTF, does the lighting bleed over there or does it not? And having a mechanism there that kind of controls that is super useful. I know from a background in game development, that was a constant issue. Like when you go inside of a building, what happens with the outside lighting, and do you keep calculating it? And so you need controls like that, or how do you fade different environment lighting based on your location and keep it really efficient? So we're having those conversations and trying to develop the external referencing such that it can handle those use cases.
Well, yeah, I could ask my question probably later, but I don't need a notebook. I actually have kind of a question for Emmett about the tone mapping that popped up in my head. And I figured it would be worth asking now rather than later. So, at my previous employer, one of the things that I always struggled with some of the artists, because we were trying to use IES light profiles when we were doing full scenes with stores. They never worked right. And I was always 100% convinced that it was because of the tone mapper within Unreal Engine. With the neutral tone mapper, is it really only oriented around like single object scenes, or does it actually work decently with larger scenes?
Yeah, great question. So I have certainly used it. It can be all right. What I generally say it's not for is what I call strongly HDR scenes. It's really designed for what I'm calling well exposed, which is really what we tend to have in that single product thing, but it's not really about it being a single product. It's about the fact that you're not trying to do some sort of filmic thing of look at the sunset, you know, like it's gonna struggle there for sure. The trade-off we made in order to retain color as well as we did is that we have much sharper gradients. We have a much more aggressive compression of the strong HDR. And that works in these product scenarios because your HDR tends to come in small highlights. And those bright spots are a narrow enough piece of the image that even if you kind of go through that gradient pretty quickly, you don't actually notice. Whereas in a sunset where that gradient is spread across the whole screen, that's not a great trade-off to make anymore. Now you need to really smooth things out, and you're going to sacrifice colors in order to achieve that. So yeah, it should, I think it'll work well in a variety of use cases, but you have to look at it, and that's actually what would be great to get feedback on, right? Because this is certainly not the be-all and end-all of tone mappers, and it'll be interesting to see if other trade-offs are better for other industries.
Yeah, I kind of wonder for AEC because just the fact that AEC is, like for the most part, they really favor unlit because of the fact that, you know, the tone mapping is consistent then. You know, everything looks consistent. And, you know, for higher fidelity scenes, I just wonder if the neutral tone mapper might work better for them.
I have the feeling, basically, I mean, I don't know if you actually mean unlit. What we often get is people using no tone mapping. We call linear or clamped tone mapping. And I would strongly recommend that anyone who is currently using linear or clamped tone mapping in a PBR rendering scenario should absolutely look at PBR neutral. That will almost assuredly, well, no, if you're truly unlit, that doesn't matter. You're not PBR at all. And then we're certainly not something to look at. This is strictly for PBR rendered scenes. Unlit means, yeah, your colors are just going to come through. You have no HDR in the first place, so there's nothing to tone map. So sure, that's all fine. But in a PBR scenario, if you disabled your tone mapping because it was giving you trouble, highly recommend you look at PBR neutral. It will actually fix a bunch of things that the clamp tone mapper will introduce, and it will also clean up a lot of nice, clean up your highlights and various things that you'll get artifacts from without any tone mapping at all.
Cool, thank you.
Hey, Emmett. Could you expand more on the lighting that you, in the diagram you had gray scale lighting? Is that an IBL, a flat grayscale lighting?
Yeah.
2 slides.
Oh, right. When I talk
There
about
we go.
here using your grayscale lighting here.
That's the one, yeah.
Yeah,
So
absolutely. So
does the paper have recommendations?
So lighting is up to you. It's an independent, choice from tone mapping. But when we talk about product scenarios, it's pretty common that people want studio lighting or neutral lighting. And I just went ahead and made that very clear that what I mean by studio or neutral is grayscale. And we do tend to look at it from an environment map perspective. Again, we find, in the modern era, we get very good performance out of environment maps, and it means you never have to worry about like the weirdnesses that you get from point lights or area lights. You can just paint in whatever shape lighting you want, and it's good to go, right? So we look at the environment lighting as a really nice, broad API for the lighting that you want. But the key aspect to why we talk about grayscale is because we actually noticed some interesting problems in GStore, which is that we were trying to figure out why our calibrated monitor colors that were picked out were different than the colors we were getting from a spectrometer of our product. And we eventually determined that the fundamental issue is the color temperature of the lighting. Retail tends to be under a 5,000 Kelvin bulb, but your monitor, sRGB, uses a 6,500 Kelvin, a much bluer white. And so there was a temptation to say like, oh, to do this truly physically accurately, we should use this orange lighting to represent what a 5,000 Kelvin lighting environment really looks like. But what we found was in practice that was just so much more trouble than it was worth. And it's actually vastly easier from a production perspective to ignore that and say, you know what, within our entire pipeline, we're working with sRGB, and we're just going to go ahead and consider white within the 6500 Kelvin band. And as long as you then know, well, I want this sRGB value on the screen, so I'm going to put that into the texture and then let it go through and not color the lighting at all, it's actually much easier to get true color representation than it is trying to do it, in some sense, fully physically accurate.
Yeah, and I can say at Wayfair, when I was working at Wayfair, we had a specific QA lighting situation. We had a grayscale interior studio lighting that we'd look at assets under and render them, and we had an outdoor that was blue, unsaturated blue sky or desaturated, and sunlight that was slightly warm. So we could get both situations and get a better sense of how the product looked in multiple situations. But primarily it's under the grayscale lighting because that gives you the accurate color that you want.
So I assume if it's no more question, so yeah, we concluded, done. Thanks for all the amazing presentations. And we have a incoming session for Vulkan, right, at 3 o'clock. Thank you.